Hello everybody, I'm Alexy Khrabrov, the organizer of SF Scala, and here we are on location at TypeSafe. And with us today we have Konrad Malawski, who is a software engineer on the Akka team.
Hello everyone.
Hello.
Yep.
So Konrad is going to talk about reactive streams. He is a well-known contributor in the Scala community, and he resides in Krakow in Poland.
Yep.
And it's not often we get Konrad in this part of the world, so we're going to ask him all kinds of questions about Scala and open source. So first of all, I noticed, through many channels, like I see a very strong open source community in Poland, specifically a lot of strong Scala-centric companies.
Yeah.
What is it about Polish open source community which kind of create this strong culture?
Yeah, so that's actually a funny story. So when I first started Scala 4 or 5 years ago, I guess, there wasn't many Scala developers, so in Krakow it was basically me. And when I would go to a meetup and say I'm really interested in Scala, people would, laugh a lot about me. Like, what is this funny language you're interested in? And nowadays, yeah, it's really crazy. Like, everybody's both into it, and actually lots of companies really centering around it on support and just helping other companies to go into it and deliver, an entire team basically to help your company start with it. So that's the usual setup I see nowadays with the new companies starting out with Scala and helping out others. So Poland is also very popular for what we call, I guess, nearshoring. So it's not outsourcing, it's just nearshoring. So people realize we really want a strong team, and I'd rather pay for a strong team and 2-3 guys and have them either visit me very often, maybe in England, maybe in Poland, maybe in Germany. So that's the usual setup, and that's how people got into Scala, I think, because there's both a very strong need in Europe for strong experts in the area, and these Polish companies kind of recognized the need and now are benefiting from it. That's fair.
Why are they kind of such a good amount of strong software engineers? Was it because of education, community? Like, what are the driving forces?
Both things that you actually mentioned. So both education is very, very strong. Like the universities in Poland are really top-notch technically. Technically has a wrong meaning in English. In technological fields, that's what I meant to say.
Yes, non-humanitarian.
Yeah, correct.
Yes.
So in Krakow we have 5 universities, and 2 of which are really like top-notch and top 10s of worldwide. Jagielloński and the AGH, which is the technology university. That's where I graduated from. And in Warsaw we have another one, which is also top 10s in the worldwide rankings. So that's one part of it. But that doesn't make a good software developer in the real world. That may make a good algorithmic person, right? But then you need to do the bridge kind of to what does actual businesses need, right? There's lots of trends and lots of technology that's somewhat related to algorithmic stuff, but not directly, right? So we have a very strong community in terms of conferences and user groups. So there's, for all kinds of technologies, user groups in many cities, so it's not very centered in only one city, but in all the cities you basically have some kind of user group for either Scala or random technology, name whatnot, right? And then we have a bunch of community-driven conferences, one of which I'm also running. It's the GeekCon conference, so Geek Conference, and it's been running 6 years now. We get 1,200 people each time, so pretty big. We rent a cinema basically.
Nice. When do you run it usually?
It's in May, every May in Krakow. And
what dates?
Second week of May always.
Okay, cool.
Yeah. If you want to come down, we usually help out. If you're from the US, for example, and you want to speak in Europe, we usually try to help out speakers to come over. Not always can we cover all the costs, but sometimes we split it up. So we pay the flight and you pay the hotel or something like that, because it's a community-driven thing.
That's good to know. May every year.
Correct.
Okay, cool.
Yeah.
Cool. I'll keep it in mind.
And because it's community-driven, and the community nowadays is very into Scala, so there's been a lot of Scala talks on that one. Even though the focus of the conference is anything around the JVM, basically.
Yes.
And nowadays, Scala is very much on top of that, and with fast data things like Spark and all the other things around it, there's really lots of Scala happening in those areas as well. So this again feeds into interest, which feeds into interest into the meetups, which feeds into good developers.
Yes.
So.
Interesting. So here's kind of question. I don't have an answer, right? I have theories, but So, for many years we have all these niche languages, and FP, functional programming, was pretty niche, and we had, Haskell, Camel,
Yeah.
and obviously Lisp before that, and Scheme,
Right. Yeah.
and Erlang, and
Yeah.
right, all kind of stuff, and it basically stays about the same size. So, meet up for some of these languages, in San Francisco, basically 20, 30 people, right? Like in a bakery.
Yeah.
When we do a meetup like tonight, we have 250 people on the wait list,
Yeah.
right? And so, what is it about Scala which made it basically the main kind of functional programming language, object functional, which broke through to mainstream?
Yeah.
I mean, it's not as big as Java, but it's fairly big,
Yeah.
right?
Yeah.
So what kind of made it, I would say, the main industry-supported functional programming language? What do you think? Why did this happen?
Right, so I think the main thing about it can be described in one word, which is pragmatism. Because, like some of the languages you said, like Haskell, very nice pure functional concepts, but not as much real-world application of them, right? And sometimes when we took concepts, that's a side story maybe, but such pure functional concepts taken from Haskell directly into Scala, one of them being enumeratees and iteratees back there a few years ago in play, turns out, well, one, they're too complex, really. It's a very nice pure model, but it's really too complex. And two, well, not that fast. Right? So it's very pure, it's very nice, and we strive to go into the functional direction of languages, but sometimes we are pragmatic enough to say, well, it's not worth the trade-off. And I think that pragmatism has driven Scala into a good spot where we do get all the benefits of functional programming and thinking in that style. However, sometimes we do acknowledge, well, sorting an array, that's the fastest way, so I'm going to sort an array.
Yes.
Right?
Makes sense. And so when people, you mentioned complexity, right? And so that's a typical objection we get, right? That kind of Scala is too complex. So when companies are evaluating this, right, how do you discuss this? Kind of what's kind of your way to discuss, this argument that Scala is complex?
Yeah, the best counterexample to that claim I have is, so before joining TypeSafe, I was working at eBay. So maybe not that known for adapting the latest and greatest. However, so we were basically one of the first teams in the London offices. And of course starting out with the existing stack, which was all Java-based and Spring-based and whatnot. However, I managed, and a few other guys managed to convince the rest of the teams to try out Scala. And well, one of the things these teams were saying then that, well, actually, this is so simple. And what I'm getting at is, well, the entirety of Scala, yeah, it's pretty complex because it's marrying a lot of concepts. However, it's doing so in a consistent way, right? So even though you learn maybe more concepts, but they fit together. So I think the term complex is overloaded. It's a broad language, as I like to put it, and you don't need to learn or even use all of the breadth of it. And even in our teams, we would decide, well, let's not go into the super advanced stuff because we're just learning, right? Because we're a new team, we're starting out. And when you actually restrain yourself to the very simple things, the good parts, as Martin likes to call them, then actually the code is both much simpler, whereas less code for one thing, and it's more type safe in terms of when you compare it to a Java, annotation-driven application, you lose all of the safety guarantees because it's now all annotation-driven, which is not type-checked at all. So you get more safety even while working on the code base. So I do think it's a sometimes misunderstood term in the from people who don't know Scala yet.
Yes, makes sense. Yeah, I remember, Martin basically has a talk where, he explains that Scala is actually simple and kind of he actually, I think, shows how, object orientation and functional programming work together. And to me, the way, like the easiest proof how simple it is the success of Spark, right? And Mark had this talk called, Spark, the ultimate Scala collections at Big Data Scala in August, and where he actually said that Spark is a Scala DSL. Right? Scala makes it very easy to write something like Spark, right? And the collection interface is very intuitive.
Yeah.
Right, so I think that's a testimony, right? In my mind, the reason for Spark adoption, one of the key reasons was the simplicity of the collection.
Yeah, exactly. Very good point. And it was both simple to write such a DSL in Scala, and then it's simple to use such a DSL in Scala for people who have actually no idea that they're using Scala, which is a pretty typical use of Scala I see in the field and even in eBay. You would get people who are very familiar with, let's say, R or MATLAB or Python, and they get a Spark script program, however you want to call it, and they just understand it.
Yes.
They don't even realize it's Scala because it just makes sense. Oh, it's a filter, it's a group, etc., etc.
Exactly. So I think, if you look at subset of Scala that's used for Spark, that's a very natural way to write data programs, right?
Exactly.
Data pipelines. So, but you're on the Akka team, and kind of like, let's kind of make a connection here, right? Because obviously, now more people are familiar with Spark and maybe with Play than with Akka, although Akka is a part of Play. And this is kind of a little bit different domains, right? So we have kind of, you cannot write an API supporting 1 million iPhones in Spark. Right? And because of this kind of widespread adoption of Spark, some people actually don't realize this. I get this question, why don't they just use Spark, right? And so there are different use cases. And so, what use cases do you see for Akka right now being a type safe? Kind of how are customers using Akka? What are the best situations where Akka shines?
Right, so at the core of it, it's really a toolkit that you can use for building either highly concurrent or highly scalable in the sense of multiple nodes, or, well, if you want to stay local, multiple threads. And the core thing about it is the concept that you use to think about it stays the same, right? Because you only think about messaging, and once you wrote in something using messaging, it feels native that it's concurrent and it can be distributed easily. So it's the opposite of what people did in previous attempts to do distributed computing, where people would hide the complexities and make it look like a method, which we believe is the wrong thing to go about it, because, well, it doesn't behave like a method because there's latencies involved. However, when you turn it around and you make messaging a first-class citizen, now suddenly you all the time realize, well, there's going to be some latency, and when I'm distributed there may be message loss, and now it feels right, it makes sense, and it's not surprising anymore. So what we see people use Akka for is when they need high throughput applications, or they need really to react very dynamically to incoming load. Like today we have a talk by the Zalando guys, but they have a very similar use case to what Guild has, right? They do flash sales, right?
Yes.
So I want to scale up to a few thousand nodes, but only basically for an hour, and then I want to scale down again.
That's why I want to be on Amazon, so I can
boom, you just add the nodes, they spread the load, and then we collapse again. And these are exactly the use cases Akka really shines because of the fast messaging, the fast connection of the cluster. I mean, the last time we benchmarked how fast a cluster can connect more nodes into it, we did a benchmark on Google's compute engine, and I think we scaled up to 5,000 nodes in 2 minutes, which is including starting the nodes.
Wow.
So
that's really impressive.
The latency of joining nodes to the cluster and they're ready to serve the requests is really, really low.
Interesting. So in Scala world we have basically two major frameworks for RPC. We have Akka, we have Finagle.
Yeah.
I don't know how much experience you have with Finagle.
A little bit, yeah.
And so in the summer we did actually the first Finagle conference as a part of Scala, by the way, and kind of it's very interesting. I'm curious, are these just two different ways of writing programs? How would one approach picking one versus the other? I've not really seen these communities overlap much, because I think Finagle in Twitter develops separately, but now it gets more into mainstream. There are some customers with Finagle. How would you compare these two things, and when one should use what?
I think nowadays, now especially, it will be a little bit closer in terms of usage patterns, especially because we have Akka streams and Akka HTTP based on Akka streams, and both of these based on reactive streams, which I'm talking about today. So the core about these APIs is one, they're type safe, as in you have the actual types of messages you can handle, which was the usual complaint against Akka. So we do have addressed that one in the new APIs.
Is it now the recommended API, the mainstream?
Yes and no. So for certain patterns, if you have a communication pattern that looks more or less like a pipeline, so stuff coming from this end to the other end, then yeah, definitely. This is the thing we do want people to use for these kinds of things. However, Akka still really shines if you have a mesh-like thing, right? For example, if you're modeling devices talking to one another, or you're doing a simulation that, you know,
you can bring up completely unpredictable device.
Correct, yeah. And it's, you know, you cannot set it up front because you don't know what it is up front. And in these situations, Akka really shines because it's so dynamic nature. And other frameworks, including Akka streams and Finagle and stuff like that, they're really not meant for peer-to-peer stuff. It's, I take in Finagle's case, a future, and I transform a future, and eventually it's going to be a response. So we take that a little bit further with Akka HTTP. So we don't say it's a future, we say it's a continuous stream of something. An example being, an HTTP server is a stream of incoming requests and a stream of outgoing responses. And this really allows for a lot of interesting implementation kind of details which affect the usage of these tools. So basically what we say, well, HTTP is such a flow of incoming requests to outgoing responses. So far so easy. However, that's basically just a wrapper on top of something which is TCP, which is incoming bytes, outgoing bytes. So we can basically exchange the underlying engine at will because it's just this flow, and we have all the infrastructure that we can dynamically compose these. So when you want to write a test, you don't need to start a server because it's just the stream. And the most interesting bit about it is the back pressure thing. So that's actually something many of the Akka support tickets from customers or complaints would be about. So sometimes customers don't really say that Akka is too slow. That rarely happens, actually. And if it happens, it's usually some silly mistake. What more often happens is Akka being too fast. And let me explain what I mean by that. It sounds like a good problem to have, but actually isn't. So what we mean by that and what customers see is that, well, for example, it's very simple to produce loads of data. And I'm just sending this data to this other node for it to work on it. But this other node can't keep up. So what ends up happening is eventually one or the other node will start buffering the data and eventually either start GCing like crazy, or it needs to drop the data, or it needs, well, or it blows up with an out-of-memory error. And this happens in all kinds of systems, but in distributed systems or in asynchronous systems in general, it's really all over the place. So reactive streams and our implementations basically address this need of communicating back pressure. So if the downstream can't keep up, I will know about that and I can do something about it. So I can use the signal to, from the pipeline, maybe add more resources or slow down the generating of the data and stuff like that. So this is actually a lesson that we've learned the hard way, yeah, exactly from our experience with customers and production systems. And also, we've used that experience both to build reactive streams and our implementations, but also to help Spark, actually. So we have a team at TypeSafe which is basically dedicated to help Spark be better. And in the latest Spark release, these, how many is it now? 3-4 guys basically spent a few months working on Spark's back pressure mechanisms, which was addressing the problem of, well, if I have a huge spike in my load, Spark is, failing. People would say that, people would not realize what's happening. What was happening is exactly that one node would be sending too much to another node in the Spark cluster, and they would, oscillate and start failing with out of memory. So lessons that we've learned on our side, we're bringing it also into other valuable projects in the Scala ecosystem like Spark, right? So that's already merged, and there's going to be more strategies coming, right? So in Spark, since you're using it for example, some analytics, right? So a valuable strategy may be to start sampling the data, right? To not collect all of it because I can't keep up. So I can collect 80, 90%, whatever, until a new node comes in, and then we can go full speed again.
Exactly.
So.
Well, this is great. So this is actually a nice connection, kind of back to Spark from like
full circle,
right? So which is probably kind of good point to wrap up and make a prediction, as we like to do. So you're on the Akka team. Obviously, there is a lot of new kind of progress, and kind of reactive systems is kind of spreading. Not, I would say, not everybody. Majority of the world does not know what we know yet, right? Like it's our job to push the technology into the world, right? And kind of, what do you think, where we're going to be in a year? You know, let's make like a prediction. So next year, like Java 1, right? Reactive systems, Akka. How many, like, what would be the adoption of reactive systems? Just, you know, what should we see? You know, what kind of customers can benefit from this? Like, any wild guesses are fine, right? Like,
wild guesses. So my wild guess is we are already seeing that, but I think it's going to pick up even more now. So we're seeing a lot of, how I call them, dinosaurs. They don't like to be called like that, and maybe I shouldn't, but you know who I mean when I say that. So they're very slowly adopting companies which like stuff that has proven over the years and, you know, are slow to adopt stuff. They are getting onto our platform, and it's stuff like banks and hotelier systems and airlines, these big players, right? And when they make decisions, it's usually both they make it very slowly, and then they need to be really convinced about it. And they don't just watch a presentation and this idea, let's use that. They really want hard numbers. And now we're pretty much in a position to show hard numbers about, you know, there's been so many actual migrations to our technologies and this style of development, reactive systems, and it has worked out for these companies. So it's finally convincing the big players to move along as well.
All right. And so hopefully it means that they will have to adopt Scala and learn it.
Along the way, I hope so.
Yeah, all right. So let's hope that reactive will be as big a driver for Scala as Spark and Play for it.
Exactly.
All right. Thanks, Konrad. We're looking forward to your talk, and thanks for coming.
Thank you very much.
Thanks.